Okay, this is lesson 5.1, and in lesson 5.1 we're going to multiply polynomials. And you've actually already done this. You've used the distributor property, which is multiplying polynomials. It's just multiplying a monomial by a binomial or a trinomial, or really any polynomial. These words, monomial, just means one term. Binomial, two terms. Trinomial, three terms. So if we look at the two examples A and B here, we've got a monomial, the number 2, multiplying by a binomial, 3x plus 4, 2 terms. In our second example, we have another monomial, negative 3, multiplying 2, 3 term polynomial or a trinomial. So let's review how to do the distributive property. When you have a polynomial multiplying by another polynomial, you have to take every term in the first polynomial and multiply it by every term in the second polynomial. And we know this as the distributive property. And when the first polynomial is a monomial, it's just taking that number, multiplying by both terms in the second polynomial. It's distributing it. It's the rainbow. So how do we distribute? Well, we have to multiply 2 by each of the terms. I'm going to show the work off to the side. 2 times 3x. When you multiply terms, you multiply the numbers and then the letters. So 2 times 3 is 6. And there's no letter in our first term, but there is a letter in our second term, so it just remains as an x. So our first multiplication results in 6x, which makes sense because really we're just doubling 3x, which is 6x. And our last one, 2 times 4 is 8. So we have 8. And that's the distributive property. Let's do one more example. We have negative 3, and in the brackets we have a trinomial, so we're going to take that negative 3 and multiply it by all 3 of these terms. The key for this one is to remember that the 3 is negative. I'm going to show the work off to the side. The first multiplication is negative 3 times 2/3 x squared. Negative 3 times 2 is negative 6, and if we divide by 3, we get negative 2. So if you don't remember how to multiply a number by a fraction, you multiply the tops, and then you divide by the bottom. And x squared, there's no letter term here, so this just remains as an x squared. So our first multiplication gives us negative 2x squared. Next one, we've got negative 3 times negative x. I'm going to write that to the side. Negative 3 times negative 1 would be the number in front, gives us 3. And there's no letter term, or no letter in the first term, so we just end up with x. So our second term is 3x. And our last multiplication is negative 3 times 2, which is negative 6. And there we go. We just distributed. We use the distributive property, one term by 3 terms. So let's expand this idea a little bit more. And now we're going to do a binomial by a binomial. And there's a nice way to remember how to multiply a binomial by a binomial, and that's called FOIL. FOIL stands for the 4 multiplications that you're going to need to do in order to multiply a binomial by a binomial. The F in FOIL stands for first. The O stands for outside. The I stands for inside. And the L stands for last. So I'm going to show you what this looks like in multiplication. So we have x plus 2 times x plus 5. And the rule is when you're using the distributive property, you have to take every term in the first polynomial and multiply it by every term in the second polynomial. There's 2 terms in the first polynomial, x and 2. So both x and 2 will need to multiply by x and 5. So I'm going to show you what that would look like. First, I'm going to do the F step of FOIL, the first step, which means take the first term in each bracket and multiply them. That's the x times the x. I'm going to write this to the side, x times x. And if we remember how to multiply letters, if they're the same letter, we add the exponents 1 and 1, and we get x squared. The O step is the outside step, which means take the terms on the outside, x and 5, and multiply them. So now we've got x times 5. The number in front of x would be 1. 1 times 5 is 5, x. And that takes care of foiling or expanding the x into both terms of the second bracket. Now we need to do it with the 2. 2 times x is our inside step. That's the two terms on the inside, the middle. 2 times x gives us 2x. And the last step is the last term in both brackets. That's 2 times 5, which is 10. And that is foiling, or expanding, using the distributive property when it's a binomial times a binomial. Now, if we look, we have some like terms here, so our last step when expanding is to collect any like terms. 5 and 2 make 7, and since we're adding, we don't add the exponents, we just add like terms, and the x stays as an x. And there's our final answer. Let's try one more example. We've got 3x plus 7 times x minus 5. We're going to use the FOIL steps again, although this time I'm not going to show my work off to the side. 3x times x is our first step. That gives us 3x squared. We add the exponents on the x, and we do 3 times 1. Next multiplication would be 3 times negative 5. Sorry, 3x times negative 5. 3 times negative 5 is negative 15, and we just have a single x. So that's the f and the o of FOIL. Now let's do the I and the L. 7 times x would give us 7x, and 7 times negative 5 would give us negative 35. And our last step, always look for any like terms. The two terms in the middle are like terms, so we're going to put them together. 3x squared minus 8x minus 35. And there we've done another example of FOIL. All right, let's try to put this all together. So these two are a little bit more complicated. If you take a look, we've got a number, a monomial, in front of a binomial, so we can just distribute the 2 to both terms. But we also have a binomial next to a binomial. And the question is, which do we do first? Well, it turns out the order doesn't actually matter. You can do the 2 times this bracket and then FOIL, or you can FOIL first and then multiply everything by negative 2. I'm going to show you both ways. So let's start with just the 2 multiplying in. The key here is that the 2 only multiplies the first bracket. It does not multiply the second bracket. And the reason why, well, if this is just multiplication, let's think for a second. If we had 2 times 3 times 4, how would we do that? Well, we'd do 2 times 3, and we get 6, and then we'd multiply by 4, and we get 24. What we wouldn't do is 2 times 3 times 4. We would not do 2 times 3 and 2 times 4 and get 6 times 8 and get 48. That would be wrong. But what we could do is we could do 2 times 4 first and get 8, and then times 3, and that would give us 24. That would be okay. But we don't distribute the 2 to both terms, because when you do multiplication, you just go left to right. So let's try one method. Let's do the 2 into the brackets first. We're going to keep our answer in a bracket because it's being multiplied by something else that's in a bracket. 2 times negative 4 is negative 8x, and negative 2 times negative 5 is 10. This is where we did the single multiplication first. And now we have a bracket times a bracket. Now we would FOIL. Negative 8 times 7 is negative 56. X times x is x squared. Negative 8x times negative 6. Negative times negative is a positive. 6 8s are 48. And we've got an x. 10 times 7x is 70x. And 10 times negative 6 is negative 60. That's where we did our double. So single multiplication and then a double multiplication. And now we can collect like terms. Collect like terms. Negative 56x squared doesn't have another term like it, but there's two x terms. If we add those together, we get 118. And that's our final answer. So that's doing the single multiplication before the double multiplication. I'm going to do another example where we do the distributive property of the double brackets first. We'll do the double first. So we'll say or. You can do it either way. And then I'll tell you which way I'd recommend. So I'm going to rewrite the question. We got negative 2, 4x minus 5, 7x minus 6. Let's do the distributive property first. Sorry, the FOIL first. Leave the negative 2 in front. 4x times 7x is 28x squared. 4x times negative 6 is negative 24x. Negative 5 times 7 is negative 35x. And negative 5 times negative 6 is positive 30. So that was our double first. And now we can see we have some like terms. So we're actually going to do the collect like terms before multiplying by 2. 28x squared, 24 and 35, both being negative, is going to be negative 59 plus 30. And now we have a number in front of a trinomial. We can distribute it in to every term. Now let's see what we get. Negative 2 times 28 is negative 56x squared. Negative 2 times negative 59 is 118x. And negative 2 times 30 is negative 60. So there we go. We end up with the exact same answer. But this time we did the double, then the collect like terms, and then the single. So which way would I recommend? Well, I personally prefer doing the double bracket times the double bracket first, and then at the end multiplying everything by whatever's in front. I think it makes it easier. When you do the single first, you end up with bigger numbers that you have to FOIL. It gets a little bit more complicated. But it doesn't matter which one you do first. All right, let's try B. B is a monster. We got a lot going on in B. If we look, we've got a number in front of a bracket with another bracket. So we've got a double and then a single in front. And over here, we've got a negative 2 in front of a bracket that's being squared. That looks a little tricky. That bracket being squared, we can make that look a little bit nicer. All right, let's give this one a shot. We're going to do the FOIL step first. But first, let's talk about what this means. When you have a bracket being squared, it's the same as having a number being squared. Like if you had 8 squared, that would just mean 8 times 8. Well, when you have a bracket squared, what it means is the bracket times itself. So really, we just have 2 of the bracket. So I'm going to write this all out. We've got 2, 3y minus 4, 2y minus 3, minus 2, and then we've got 4y plus 1, and there's 2 of those brackets, 4y plus 1. So we can actually do this as 2 parts. We can do this whole first part just like we did this example, and then we can do this whole second part just like we did this example, and then at the end we put all our terms together. So let's give it a shot. We're going to do the FOIL step first on each of these brackets, and we're going to do it at the same time. So let's see what we do. We leave the 2 in front. We're going to open up a big bracket, and let's FOIL. 3y times 2y is 6y squared. 3y times negative 3 is negative 9y. Negative 4 times 2y is negative 8y. And negative 4 times negative 3 is 12. Next terms, we've got negative 2, and we're going to do the FOIL first. So a big bracket, 4y times 4y is 16y squared. 4y times 1 is 4y. 1 times 4y is also 4y. And 1 times 1 is 1. So there we go. We did 2 FOILs at once. Now why did I put my answer in brackets? Well, I put my answer in brackets because there's a 2 in front of the first bracket. So that means 2 needs to multiply by everything. So we need to figure out what everything is first and then multiply by 2. In fact, actually, we've got some like terms here. We should probably collect those first. 6y squared minus 9 and minus 7 is negative 17. And then 16y squared, 4y and 4y is 8y. And now we can distribute in the numbers. We've got 2 times 6y squared, 2 times negative 17y, and 2 times 12. Well, that would be 12y squared, negative 34y, plus 24. Once we do our last multiplication, that opens up the brackets, and now we don't have any terms in brackets. Last example, we've got negative 2 in front of 3 terms, so it's negative 2 that multiplies in, not just 2, negative 2. So negative 2 times 16 is negative 32y squared. Negative 2 times 8 is negative 16y, and negative 2 times 1 is negative 2. There we go. And our last step is to collect like terms. So let's give that a shot. Y squareds. Well, we've got a y squared here and a y squared there. If we put those together, we get negative 20y squared. And then we've got a y here and a y here. If we put those together, we get negative 50y. And our numbers, we got 24 and negative 2. Put those together, we get positive 22. And that is as complicated as expanding can get. And it does look pretty complicated, but it's the same 3 steps over and over and over again. We got a FOIL step, there's a distributive property, and collecting like terms. That's it. No matter how complicated I make it, it's just foiling, distributing, and collecting like terms. All right, that's it for lesson 5.1. Thanks for watching, and I'll see you in lesson 5.2.